Lastly, understanding Ohm's law. Say that you're wiring a circuit. You know the amount of current that the component can withstand without blowing up and how much voltage the power source applies. So you have to come up with an amount of resistance that keeps the current below the blowing up level. Now, in the early 1800s, George Ohm published an equation called the Ohm's law that allows you to make this calculation. Ohm's law states that the voltage equals current multiplied by resistance, or in standard mathematical notation, you can see here V is equals to I times R. I stands for inductance and R is resistance. Now when we take Ohm's law further, remember in your high school algebra, remember how if you know two things such as x and y, in an equation of three variables, you can actually calculate that third thing. Ohm's law works that way actually. You can rearrange its elements so that if you know any two of the three values in the equation, you can just calculate the third. So here, how you can calculate current. Current equals voltage divided by resistance, or you can see in the slide, I equals to V divided by R. You can also rearrange Ohm's law so that you can calculate resistance if you know voltage and current. So resistance equals voltage divided by current, or R equals to V divided by I. So far, so good. Now, take a specific example using a circuit with a 12-volt battery and a light bulb, basically a big flashlight. Before installing the battery, you measure the resistance of the circuit with a multimeter and find its 9 ohms. Now here's the formula to calculate the current. So current is equals to voltage divided to resistance. So we have our voltage as 12 volts and our resistance in 9 ohms. That is given already. So this is equivalent to 1.3 amps or current. Now, what if you find that your light bulb is too bright? A lower current reduces the brightness of the light, so just add a resistor to lower the current. Originally, we had 9 ohms, right? Now, adding a 5 ohm resistor to the circuit makes the total resistance to 14 ohms. In this case, the formula for current is equivalent to voltage divided by resistance. So we have our volts, 12 volts, and then 14 ohms for resistance. So this is equivalent to 0.9 amps current. Now, dealing with numbers both big and small. Say that you have a circuit with a buzzer that has a resistance of 2 kilo ohms and 12-volt battery. You don't use 2 kilo ohms in the calculation. To calculate the current, you have to state the resistance in the basic units. Without using the kilo prefix in this example, that means that you have to use 2000 ohms for the calculation, like this. So current is equivalent to volts divided by resistance. So we have 12 volts and we have 2000 resistance. So this is equivalent to 0.006 amps or current. You now have the calculated current stated as a fraction of amps. After you finish the calculation, you can use a prefix to restate the current more succinctly as 60 milliamps or 6 mA. The bottom line, you have to translate any measurement expressed with a prefix to base units to do a calculation. Lastly, the power of Ohm's law. Ohm's actually also expressed that power is related to voltage and current using this equation. Power is equivalent to voltage times current, or power voltage times current. You can use this equation to calculate the power consumed by the buzzer in the previous section. So we have power is equivalent to 12 volts multiplied by 0.006 amps. Then this is equivalent to 0.072 watts, which is 72 milliwatts or 72 MW. Now, what if you don't know the voltage? What if? So you can use another trick from algebra, because voltage or volts is equivalent to current multiplied by resistance, you can substitute resistance multiplied by current into this equation, giving you power current raised to the power of 2 times resistance, or power current squared times resistance. So another tip, you can also use algebra to rearrange the equation for power to show how many you can calculate resistance, voltage, and current if you know power and any of these parameters. Once again, thank you for listening. If you have any further questions, don't hesitate to message me anytime.